How can we explain if a number is rational or irrational? Well, the name itself, rational, has a word ratio in it, and ratios are just two numbers being compared to each other, usually with division, in fact, and that makes it a fraction, right? One number on top divided by a number on the bottom. That is a fraction. So that means if we can make that number into a fraction, it's rational. And it becomes very easy if we're already looking at a fraction. If it's a fraction, it's rational. What about a mixed number? Well, any mixed number we can turn into a fraction. So there you have it. All mixed numbers are rational. What about a decimal? Well, 4 and 1/10, for an example. It's a terminating decimal. It stops. It just ends. We can make that into a mixed number real easy, 4 and 1/10, right? And then we can make that into a fraction. So yes, that decimal is a rational number. What about if it doesn't terminate like that 4.1, right? What if it just repeats 0.272727? No problem. Every single repeating decimal we can make into a fraction. It's got a different set of rules, but we can do it, so it's rational. What about a square root? Well, if it has a whole number for the answer, if it's a perfect square root, like this one, the answer is 3. We can make that into a fraction, so we know that the perfect square roots are rational. What about irrational numbers? Well, it's the exact opposite. Those are the ones that we can't make into a fraction. And in fact, if you take a look at this part of the word irrational, the IR in front, it's kind of like another way of saying not rational, not able to make it into a fraction. And it has a totally different type of situation there. Take a look at the decimals. Both of those decimals and those imperfect square roots, they go on forever without a pattern, just like the pi down there. And so if pi is ever involved, or if an imperfect square root is ever involved, those decimals go on forever, just like the repeating decimal, but there's no pattern. So they're very similar to each other, these imperfect square roots and pi. And as a result, we just know there's no way to turn them into fractions. And that is how you can explain whether a number is rational or irrational. One other thing to take a look at though, and I just want to point this out. Decimals that stop, like this 4.1, or decimals that repeat in a pattern that go on forever but they repeat, those are rational. The decimals that go on forever with no pattern, like the imperfect square roots and the pi's, those are the ones that we can't turn into a fraction.